Hello again, everyone. Mr. Cruze here with another review for you. This time, trigonometry. How to graph the trig functions, at least the basic trig functions, sine and cosine. Alright? Remember, you have a quiz tomorrow. It'll be 6 questions. All it is graphing. Alright? You'll see equations in one of the following two forms. Y equals c plus a sine of b times the quantity x minus d, or the same thing just with cosine instead of sine. First things first, I want to go over just what these letters mean. If you can identify them, you should be pretty good. Alright, so let's review. A is your amplitude. Okay. I guess I suppose I should say absolute value of A is your amplitude. A could be a negative number. Okay. If A is a negative number, just remember that that kind of flips your graph upside down. So if it was negative, sine would go down first. If it were negative for cosine, it would start at a low point instead of at a high point. Okay, but the absolute value of A is your amplitude. B helps us find our period. Helps find period using the following formula: either 2 pi divided by B or 360 divided by B. That'll tell you your period, depending on if you're in radians or degrees. C tells you to move the entire graph up or down, and how much, right? If C is positive, it tells you to move it up however much. If it's negative, it tells you to move it down however much. D, which you'll notice, by the way, is the opposite of what you see inside, right? Because we see negative D. So D tells you to move it left or right. Okay, so C and D affect up, down, left, right movement. Okay? If you know those things, this shouldn't be the worst thing we've done all year. So let's try a few. We'll start with some basic ones first. So this is from that extra review sheet that I gave you. Number 1 on the front is y equals negative 2 sine theta. Also remember theta, that means we're going to be in degrees. Degrees are arguably a little easier. So I just start off, well, what's our A value, what's our B value, what's C, what's D? So A is the number that's right in front of the sine, right? So A is negative 2. B is the number right in front of the theta, which happens to be 1 in this case. Okay. C happens to be whatever's added on at the front. I guess that's probably labeled as A, B. C is whatever happens to be added onto the front, which appears to be nothing. D is what happens to be added or subtracted onto the theta, which is also nothing. So you'll notice this time no left or right or up or down movement. Okay. So really the only thing that's changed is our amplitude is 2, and our B value is not even changed. It's 1. So let's start graphing this. And we're only graphing one cycle. So that's good. So A is negative 2. That means my amplitude is 2. So the highest it's going to go is 2, and the lowest it's going to go is negative 2. Our B values, so I need to find our period. That's we're in degrees, so it's 360 divided by 1. So that means we're going to do one full cycle in 360 degrees. Okay. Now I just need to figure out what I need to add each time. So to do that, you divide by 4. And that means we're going to be adding 90 every time. So obviously if I start at 0, my first critical point will be at 90 degrees. My second one will be at 180. My next one will be at 270. And my final one will be at 360. Okay, you're just adding 90 every time. The only thing left to do now is graph it. So I'll use pink. So it's sine. Sine starts on the axis. Okay. But since A is negative, that means it's going to go down first. So at 90, it'll be at negative 2. At 180, it'll be back at 0. 270 will be back at 2. And 360 will be back here. And you just kind of try to connect it with the smoothest curve possible. Good enough. We're not looking to build a watch here, so we're okay. There it is. Y equals negative 2 sine theta. Not so bad once you can identify the letters, right? Pretty good, pretty good. Alright, y equals 1.5 cosine 4x. Alright, so y equals 1.5 cosine 4x. So again, let's start off by identifying our A, our B, our C, and our D. A is the number right in front, which in this case would be 1.5. B is the number in front of the x. Hey, that's a 4. C is what would be added on the front, which is nothing. D is what's added onto the x, which is, again, nothing. So again, no up, down, left, or right shift. Okay? That kind of makes life a little easier. Also notice, by the way, that we're using x. That means we are in radians, not degrees. So please be careful. Everything's going to be in terms of 2 pi, not 360. Alright, so here we go. Cosine. Our amplitude's 1.5, so our high point's 1.5, and our low point's negative 1.5. I guess I went up 4 on the top, so I should probably go down 4 on the bottom. Again, try to be accurate as possible, but we're not too picky here. I just want to make sure you can graph these. No left or right, no up or down, so we're good. B value, so I need to use the B value to find the period. So 2 pi divided by B gives us our period, which is pi over 2. Okay, so that means we're going to be doing 1 complete cycle in pi over 2 radians. Divide that by 4, or rather multiply it by 1/4, and that'll tell you what to add each time. So pi over 8. And I think this is the part right here where it gets complicated, because it deals with fractions, so we have to be careful. But it doesn't matter, we're just adding pi over 8 each time. Or 1/8 pi, if you want to think about it that way. So we're starting off 0, obviously. That's our first critical point. If you want to label 0, you can. Add pi over 8, so our first value is pi over 8. And keep adding it until you get 5 critical points. I will reduce at the end, so pi over 8 plus another pi over 8 is 2 pi over 8. Again is 3 pi over 8, and finally is 4 pi over 8. Now, that's fine to do that. Make sure you keep common denominators, that way you can just keep adding. But please go back and reduce them, right? So for instance here, 2 pi over 8 reduces to pi over 4. 3 pi over 8 is good. 4 pi over 8 reduces to pi over 2. By the way, no surprise, we started at 0, and we said our period was pi over 2. It should end at pi over 2. So there's our 5 critical points. 0, pi over 8, pi over 4, 3 pi over 8, and pi over 2. Our A value is positive this time, so cosine will start at a high point, not a low point. And at pi over 8 it'll be at 0. At pi over 4 it'll be at negative 1.5. Back to 0. Back to 1.5. And you just try and connect it with as smooth of a graph as possible. We could probably do a little better than that. But again, we're not being too picky here. We're just doing the best we can. Alright. 2 graphs down. Now we start getting into a little more of the fun ones. So y equals negative 2 plus sine of 2 theta. Notice this one's a little different. We have a negative 2 plus this time. Also, notice we're in theta again, so we're in degree mode, so keep that in mind. Let's identify our A, our B, our C, and our D values. A is the number right in front of the sign, which in this case is a positive 1, so our amplitude is just 1. B is the number in front of the theta, so that'd be 2. C is the number that's added or subtracted onto the front. That would be a negative 2. So this time we actually have a C value. D is what's added on to the theta or the x. In this case, that'd be 0. So let's think about this. This here means we have an amplitude of 1. This is going to change our period, right? Not 2 pi. We said it was in degrees, right? 360 divided by 2 means our period is 180. This means we move our entire graph down 2 units. Okay? So we're basically moving the entire x-axis down 2 units. So instead of starting at 0, now we're starting at negative 2. This is our new x-axis, if you will. That's going to be the new middle of our graph, basically. Okay? Our amplitude's 1, so we're going to go 1 up and 1 down from our new x-axis. So negative 3 is our new low point. Negative 1 is our new high point. My graph, you don't even really need these dotted lines, but my graph cannot go beyond those 2 values. Okay? Let's see if this is purple again. Yes, okay. So, here we go. I said our period's 180. I'm going to divide that by 4 to figure out what to add each time. That'll be 45 degrees. So my first value obviously is 0. Next one will be 45 degrees, followed by 90 degrees, followed by 135, followed by 180. Again, just adding 45 every time. This was sine, so it starts on the axis. Remember, this is our new axis, though. Not the old one. It's our new axis. Everything's shifted down 2 units. Our A value is positive, so we're going to go up first. So 45, back down into 0 at 90, or our new 0, rather. 135, and then 180, so. And there you go. 1 cycle. Not too bad, is it? Just remember, the C moves everything up or down. Alright, this is the last one I'm going to do for this video. Y equals 2 plus 1/2 cosine of 2 times the quantity x minus pi over 2. First thing I notice, x, boom, radians. Okay, just be careful with that. Make sure you don't mix that up. That'd be a silly thing to get wrong. Let's see, a value, b value, c value, and d value. A is the number right in front of the cosine, that's 1/2, so our amplitude is 1/2. B is the number right in front of the x, which would be a 2 in this case. C is what's added up front, that's a 2 as well. And D is the opposite of what you see in here. So I look at it and I see a negative pi over 2, take the opposite, it's going to be pi over 2. Basically, it's the number that if I plugged it in, it would make that 0, right? It would make it the new 0, and that'd be positive pi over 2. I always just recommend taking the opposite of what you see. So we're actually going to be moving to the right pi over 2 units. Okay? So yeah, the C value tells me to move up 2, and the D tells me I'm going to move right, since it's positive, pi over 2 units. Okay. So let's start by making our axes. I know I'm going to go up 2, so I'm going to kind of be careful here. So up 2 units, so we're going to move the entire x-axis up 2 units. So here is our new x-axis, if you will. Our amplitude is now 1/2, which means from the new axis, I'm going to go up 1/2 to 2.5, and I'm going to go down 1/2 to 1.5, and those are my new high points and low points. Okay? This is a very compressed graph. It could be worse, though, but it's very compressed for what we've got. Okay? Now, I have to move everything right pi over 2, so I'm not actually starting at 0 anymore. I'm actually going to start at pi over 2. Alright, so again, this is, if you want, you don't have to put this in, but this is kind of my new y-axis, if you will. It kind of functions that way. Alright, so let's figure out what we have to add every time. Our period, obviously we're in radians, will be 2 pi divided by our b value, which is just pi, so we're going to do one full graph in pi units. To figure out what we add each time, we divide that by 4, which is obviously just pi over 4. Nothing really special there, but you're going to add pi over 4 each time. But you're not starting from 0. You're starting from this point, pi over 2. So I need to figure out, well, how do I take pi over 2 and add to it pi over 4? Remember, with fractions, you need common denominators. So, obviously, common denominator here between 2 and 4 is 4, so I don't really have to change pi over 4 at all. But I'm going to change pi over 2 to 2 pi over 4. Multiply the top and the bottom by 2. And now I can successfully add them, right? Pi over 2 plus pi over 4 would be, maybe I'll make it a little closer, would be 3 pi over 4. And then just keep adding pi over 4. That's what you're supposed to add every time, right? So 3 pi over 4 plus pi over 4 is 4 pi over 4, and we'll reduce later. Continue to do this until you get 5 critical points. 1, 2, 3, 4, 5 critical points. Now I'm going to go back and reduce them. 4 pi over 4 is the same as just 1 pi, right? 5 pi over 4 won't reduce. 6 pi over 4 will be 3 pi over 2. And then you've got it. This is probably the hardest part, just getting common denominators and figuring out what to add each time. But if you take it slowly, you can do it. And then you just have to graph it. This is cosine, so it'll start on the, or at a high point. But remember, not at 0 this time, it starts at pi over 2. Also, my a value is positive, so that's why it's starting at a high point. Go to the new 0 at 3 pi over 4. And it'll go down, and then it'll come back up. So there's my artist approximation of this graph. Okay, and again, we're not looking for perfection here. Mostly what I'm looking for is, do you have these numbers right? Do you have these numbers right? And do you have the correct graph? Did you graph cosine instead of sine? Okay? Good luck, guys. Like I said, 6 problems. This is all this is. So as long as you know how to graph these, you should be great. If you have any questions, please tweet me at Mr. Cruze Math, or leave a comment on this video, or as always, see me in the morning for help. See you guys then.